Welcome back to my channel. Today, we just continue the proving identities, which we have done in the previous videos, right? So before we start, let me recall those techniques that we discussed during the proving identities. And that is, the first thing is here, the convert every ratios in one design and cost, right? That we discussed earlier. The next one is that change in direct formula. Direct formula, you know that, right? Now, next is factorize the given expression. And finally, remember, always keep your eyes on the right hand side, that to be proved. Okay, these are the certain things that you need to remember always. Okay, now here, let's get this example here. Now here, let's take the LHS, right? Now, this expression is already in the terms of sine and cos. We don't need to change in the sine and cos. Here, 1 minus sine alpha, we can't do anything here. But what about sine square alpha, right? So can I just change like this? Sine square alpha as a 1 minus cos square alpha and a cos square alpha as 1 minus sine square alpha, right? Now, if you look into the 1 minus cos square alpha, that is exactly in the form of a square minus b square. And we know that a square minus b square is equal to a plus b times a minus b. So if you consider 1 as a 1 square and cos square alpha, then that is a square minus b square, where 1 is a and cos alpha is a b. Similarly, in the denominator, 1 is a and sine alpha is a b. Now we can use a square minus b square form as like this. 1 minus sine alpha times, okay, 1 minus cos square alpha is 1 plus cos alpha times 1 minus cos alpha. And 1 minus sine square alpha is 1 plus sine alpha and 1 minus sine alpha. It is simply, I'm using here a square minus b square form. Now we can cancel 1 minus sine alpha and 1 minus sine alpha. Then 1 minus cos alpha, 1 plus cos alpha and 1 plus cos alpha, right? Then what remain here? It is 1 minus cos alpha and 1 plus sine alpha, which is the right hand side, and it's proved. Okay, let's look at the next example here. Okay, let's take the LHS. Now here, look at closely here. If you look at the denominator, we are going to take the LCM. But before we take LCM, look at this carefully. One is tan A minus 1, another side that is 1 minus tan A, which are look like similar. What happens if I make 1 minus tan A as a tan A minus 1? Okay, it will be like this. Once I make this 1 minus tan A as a tan A minus 1, then that main sign that is plus will become minus, because we are taking minus as a common, and that will affect that plus. So plus will become minus. Okay, now here, there is in the denominator is a tan A minus 1 and tan A minus 1. So we can take LCM easily. So if you take LCM, tan A minus 1, then there will be tan square A minus cot A. Okay, now here, look at here. If we change cot A, everything is tan except cot. We can change cot as a in terms of tan. So can I do like this? Tan square A minus cot A is 1 on tan A, and divided by tan A minus 1. Okay, now here it seems like everything is in terms of tan. So we can take the LCM here. And when you take the LCM, then remember it is tan cube A minus 1 upon tan A. Tan A is the LCM, right? And in the denominator, tan A minus 1 as it is. Now, let me show you something here. If you closely look at here, okay, if you closely look at here, see this one. Okay, look at this one. What is this? It is look like tan cube A minus 1, which is in the form of A cube minus B cube. Do you remember what is A cube minus B cube? It is A minus B times A square plus AB plus B square. You remember that, okay? A cube minus B cube. Now here, when you look at the tan cube A minus 1, tan A is A and 1 as a B. So it is A cube minus B cube. Let's use this form here, okay? How can we use it? Let's see. We just simply do that, okay? A cube minus B cube. Look at here. Tan A minus 1. Tan A is A, 1 is a B. So it is A minus B. Now A square plus AB plus B square. Where A square means it is a tan A whole square. That is tan square A plus AB. A is tan A and B is 1. So tan A times 1 is tan A. And plus B square, that is 1 square. And that is 1. And upon tan A, right? And into reciprocal concept here. It is 1 upon tan A minus 1. Okay, now if you look at here, we can simply cancel tan A minus 1 and tan A minus 1. Okay, now when we do that, remember we'll be getting here simply tan square A plus tan A plus 1 upon tan A. Okay, now look at here. We can do like this. We just separate the denominator. I gave this concept previously. If you don't understand this concept, you can just watch my previous video. I'm just simply separating the denominator, right? Tan A. Tan A is the denominator. I'm separating that. If I take the LCM, once again, I'll be getting back the previous term, okay? Now look at here. If I cancel tan square upon tan A, now we'll be getting something like this. Tan square upon tan A is tan A plus tan A upon tan A is 1 and 1 upon tan A is cot A. Remember, 1 upon tan A is cot A. Okay. Now let's change tan A and cot A in terms of sine and cos. That's a technique. Okay. Always. Sine upon cos A plus 1 plus cos A upon sine A. Now we can take the LCM between sine A upon cos A and cos A upon sine A. Then we'll be getting like this. Cos A times sine A. And here is a sine square A plus cos square A. And plus 1, I separate it on the other side, right? Now, from here, we know sine square A plus cos square A is 1. So can I be write like this? 1 upon cos A times sine A plus 1. Okay, now I can separate like this. 1 upon cos A times 1 upon sine A plus 1. Okay, here it is 1 plus 1 upon cos A is sec A and 1 upon sine A is cosec A. And that is the right hand side. And that is proved. Okay, let's go for the next example. Here, okay, here, this is another problem. Okay, and here, uh, let's take the LHS. Okay, here I'm taking the LHS here. Look at this problem here. Now here the denominator I can separate like this. Okay, 1 upon cos to the power 4a plus sine to the power 4a upon cos to the power 4a. And this is the same technique as we do like this. A plus b by c. We can simply do a by c plus b by c. Try to take the LCM, you'll be getting a plus b by c again. Okay, now we are using the same technique here. Okay, now what is 1 upon cos to the power 4a? It is sec to the power 4a. And sine by cos is tan, so it is tan to the power 4a. Now, I'll give you the one formula, one form, which is very important. Look at here. You know that a square plus b square is equal to a minus b times a minus b whole square plus 2ab. Okay, I hope this you remember. Okay, a square plus b square form. Now, look at this term here sec to the power 4a plus tan to the power 4a. Can I do like this? Sec square a whole square plus tan square a whole square. Now it is exactly in the form of a square plus b square, where a means sec square a and b is tan square a. Can I compare with a square plus b square? Then what will happen? It is just like the a minus b whole square plus 2ab. You have to write it. So it will be something like that. Sec square a minus tan square a whole square plus 2 sec square a tan square a. Here, sec square a is a, tan square a is a b. So it is a minus b whole square and plus 2ab. A is sec square a and b is tan square a, right? Just compare with the a square plus b square. Now, you know sec square a minus tan square a is a 1. So can I write 1 square plus 2 sec square a times tan square a, and that is equal to 1 plus 2 sec square a times tan square a, and that is the right hand side, okay, which is proved. Remember, always keep your eyes on the right hand side. According to the right hand side will guide you to get the, okay, to simplify, to factorize, whatever, okay, to just to get the right hand side, always you need to keep your eyes on the right hand side. Okay, let's go for the next example here. Look at this problem here. Okay, here I'm taking the LHS, right? And here, now see, you remember the formula. A plus b whole square equals to a square plus 2ab plus b square. Okay, can I use the whole square concept here? But here are the three terms. And look at the right hand side. We need a 1 plus sine a and 1 plus cos a, right? Okay, I will just do one thing here. I'm taking 1 plus sine a as a, I'm considering, okay? And a cos a as a b. Okay, remember 1 plus sine a is a and cos a is a b. Now if I do so, a plus b whole square equals to a square plus 2ab plus b square, right? Can you use the same condition here? Let's expand it, considering 1 plus sine a as a and a cos a as a b. So it will be like this. 1 plus sine a whole square, that is a square, plus 2ab. 2a, a means 1 plus sine a, b means cos a, right? Plus b square, and b square is cos a, and cos square a. I'm just expanding exactly as a plus b whole square, right? Now here, look at here. 1 plus sine a whole square. Can I expand it again in the same a plus b whole square form? It will be something like that. See, 1 is a, sine a is a b. So 1 plus 2 sine a, that is a times b is 1. And sine a times 1 is sine a. So it is 2 sine a plus b sine a. So it is a b square and sine square a. And plus rest as it is, right? I didn't do anything. So it is a plus 2 times 1 plus sine A times cos A plus cos square A as it is, right? Now from here, I'm just trying to keep here. Look at this term, sine square A and a cos square A. Can I keep them together like this? 1 plus 2 sine A plus sine square A plus cos square A and plus rest that is the same as a 2 times 1 plus sine A times cos A. So I'm just keeping sine square A plus cos square A together just to make it 1 because we know sine square A plus cos square A is 1. So let's keep it 1 plus 2 sine A plus sine square A plus cos square A, that is 1. Okay, plus. Now the rest is the same. 2 times 1 plus sine A times cos A. Okay, now here 1 plus 1, we can just make it 2 and it's 2 plus 2 sine A plus, and that is the same 2 1 plus sine A times cos A, right? Now look at here. Look at the first two terms, 2 plus 2 sine A. Can I take a common? And that is 2 is a common. If I take a 2 common, then it will be 1 plus sine A will remain and plus 2 1 plus sine A times cos A. Okay, now that's a very important thing. Let me just show you here. If you look into this here, can you see this part? Look at this. It is 2 1 plus sine A, and here is also 2 1 plus sine A, right? In these two terms here, can I take this as a common? And if I take a common, okay, let's see what happened here. If I take a common, remember I'm taking 2 1 plus sine A as a common. Then if I take that common, see 2 times 1 plus sine A is a common. Then what will remain? It will be 2 plus 1, 2 times 1 plus sine A, it will become 1 and plus I've already taken 2 1 plus sine A, just remove it. Then what will remain? It is a cos A. Okay, and that is the right hand side. Okay, which I think it's proved here. Okay, now let's move to the next problem. Okay, and here, look at this. Okay, here, see, I'm taking the LHS once again. Here, just I want to say something here. Look at this, sec A minus tan A plus 1 upon sec A minus tan A minus 1. Okay, and here, if you look into this only, simply look at this part. It is 1 and this is 1 here. And just remember, can I change this 1 in terms of secant tan? Because we know there's a certain formula which gives you 1. Let me tell you, sine square A plus cos square A equals to 1. You know that, right? Sec square A minus tan square A is also 1. Since here is sec A minus tan A, can I relate 1 with a secant tan A? So for that reason, what can I do? Look at here. I can simply change this 1 into sec square A minus tan square A like this. Okay? I can just simply like this. Look at the 1. I change 1 in terms of sec square A minus tan square A. Denominator also I did the same. Now remember, sec square A minus tan square A just like A square minus B square. Okay, and what is A square minus B square? A square minus B square is A plus B times A minus B. Here, A is sec A and B is tan A. So let's change it. Okay, here it will be like this. Sec A minus tan A plus, remember, it is A plus B, A minus B, where A means sec A and B means tan A. So it is sec A plus tan A, A plus B, sec A minus tan A, A minus B. Denominator, I did the same here. Okay. Now here, once again, can you see closely here? What did you see here? Look at this. This is person. If you look at here, this sec A minus tan A, and here this one is sec A minus tan A. This is the common. We can take a common here. In the denominator, also the similar thing you can see here. See, it is sec A minus tan A, and here this is sec A minus tan A. I can take common in the denominator as well, right? Now, if we do so here, let's take the common. If I take a common, sec A minus tan A, just common means just remove it from that term. So what will remain? In the first term, sec A minus tan A, there is nothing. So there is 1, then plus, then what remains? Sec A plus tan A, right? In the denominator, sec A minus tan A, and here is a 1 minus, okay? Remember what remains? Sec A plus tan A. But I have written here sec A minus tan A. Do you know why? Because there is a minus outside. So minus will change the sign and the plus tan A becomes minus tan A, okay? Now here, we can simply cancel sec A minus tan A and sec A minus tan A. Then what remains? 1 plus sec A plus tan A and 1 minus sec A minus tan A, and that is equal to right hand side, and that is proved. Okay, now let's move to the next problem, and here this is the another one. Okay, and this is a little bit different here. Look at here, I'm taking the LHS where 3 minus 4 sine square theta, 1 minus 3 tan square theta. Now let's consider how can we get the right answer. I always told you that keep your eyes on the right hand side. And on the right hand side, we need a cos and we need a tan. Now here's a sine and a tan. So for the moment, let's just try to do in this way. Can I change tan square theta in terms of sine and cos? See, tan square theta is sine square theta upon cos square theta. Okay, 3 minus 4 sine square theta, I did nothing for the moment. Okay, now what I do here, I simply take the LCM. And in that part, when I take cos square theta as a LCM, then there will be cos square theta minus 3 sine square theta. Okay, you know how to take the LCM, right? Now after that, look at here, what I did here. Can you see? I just keep cos squared theta under 3 minus 4 sine squared theta. It is a multiply sign, so I can keep cos squared theta anywhere. Okay, so it will become like this 3 minus 4 sine squared theta divided by cos squared theta. Okay, now here cos squared theta minus 3 sine squared theta is there. It's a multiple sign. Remember, just I'm keeping cos squared theta under cos squared theta. Okay, now here, look at this. What I did here. See, exactly the concept that I use. Cos squared theta is separate here. 3 upon cos squared theta minus 4 sine squared theta upon cos squared theta. Okay, and look at another bracket part. Cos squared theta minus 3 times sine squared theta I changed into 1 minus cos squared theta. Why did I change? Because look at the right hand side. We need cos, not sine. So sine should be changed in terms of cos, and sine squared theta is equal to 1 minus cos squared theta. Okay, look at here. Look at the first bracket here. 3 upon cos squared theta. Is it 1 upon cos squared theta? Can I make it like this? 3 sec squared theta. We know 1 upon cos squared theta is sec squared theta minus sine upon cos is tan. So it is minus 4 tan squared theta. Okay. And another bracket, let's simplify. Cos squared theta multiplied by the 3. It is minus 3. And minus minus becomes plus. And this is 3 times cos squared theta is 3 cos squared theta. Now, see, once again, I'm telling you, keep your eyes on the right-hand side. In the right-hand side, we don't need sec. So can I check sec? Can I change sec in terms of tan? And we know that sec squared theta is 1 plus tan squared theta. So let's keep it. 3 times 1 plus tan squared theta minus 4 tan squared theta. And another bracket, it is a 3 cos squared theta plus cos squared theta. Cos squared theta makes 4 cos squared theta minus 3. Look at the right-hand side, we got it. 4 cos squared theta minus 1 minus 3, right? Now, let's simplify a little bit more. It is 3 plus 3 tan squared theta minus 4 tan squared theta. And 4 cos squared theta minus 3 as it is, right? Now, let's look at here. It is 3. Now, look at here. 3 tan squared theta minus 4 tan squared theta gives you the tan squared theta. 3 minus 4 gives you minus 1. So, it is 3 minus tan squared theta. And another part, 4 cos squared theta minus 3 as it is. And look at this. Both are the right-hand side. So, this is the right-hand side and it's proved.